At-Risk's project tool allows you to build a risk register that can be included in a simulation of a project schedule. A risk register lists possible risk events that can impact a project schedule and its costs. Typically, each risk event has a probability of occurrence, so that it either occurs or it doesn't. If the risk occurs, the size of the impact of the risk is typically also uncertain. To learn about risk registers, you can open the Excel file Simple Risk Register. This file is in the at-risk example files and is linked to a project MPP file of the same name. It has already been opened here. Remember that this also opens the corresponding MPP file in Microsoft Project. An Excel worksheet is a good place to build a risk register. The row and column format makes entering a table of risks straightforward. At-risk can be used for defining distributions that determine whether a risk occurs, and if so, the size of its impact. In this case, the probability column shows the probability of a given risk occurring. Risk discrete distributions entered in the simulated occurrence column use this probability to sample whether a risk occurs. If a risk does occur, it causes a schedule impact, sampled from a risk PERT distribution with min, most likely, and max values shown in the schedule impact columns. The risk can also have a cost impact, sampled from a risk trying distribution with min, most likely, and max values shown in the cost impact columns. Of course, you can use any of at-risk's distribution functions to model impacts in a risk register. Once you have built a risk register, you need to link it to your project schedule. There are different ways to create the link. The simplest method is to add a simulated schedule or cost impact directly in a formula in Excel. This method is used for the environmental risk in row 6. The corresponding link is in cell C5 of the tasks sheet. During a simulation, this formula calculates the duration of the cleanup task by summing two values. First, the PERT distribution generates a base distribution from 25 to 35 days. Then the impact of the environmental risk from the register is added, but only if this risk occurs. Risks from a register can also be linked to a schedule using risk project functions. One of these functions is called risk project add delay. The effect of this function is to add an additional task and associated costs to the schedule if a risk occurs. The idea is that a risk event often does not directly impact the schedule and cost of an existing task. The risk event can instead cause a new activity to take place, with its own duration and costs. In this example, the customer design approval risk in row 5 results in an additional task and associated costs being added to the schedule if the risk occurs. This new task will take place after the original design task, perhaps due to added design revisions and reviews. The new task has a varying length and cost, as calculated in the register. When appropriate during the simulation, the at-risk function risk_project_add_delay adds this new risk-related task after the design task. You can look at the formula in cell V5 on the register sheet to see this function. Its first argument is a reference to the task in the schedule where the new task will be inserted if the risk occurs. In this case, if the risk occurs, the new task will follow the design task, B3 in the tasks sheet. And the existing successor tasks to design will now come after the new task. It is as if a new task with its own duration and costs is dropped in the middle of the schedule when the risk occurs. A second risk project function called risk_project_add_cost adds an additional risk-related cost at a time specified. When a risk event occurs, this function adds a cost only to the project's cost calculations. In this example, the material price risk in row 7 results in an additional cost being added to the project when this risk occurs. This risk could be additional raw material costs that are incurred anywhere within a specified time frame. When appropriate during the simulation, the at-risk function, risk project add cost, adds this new risk-related cost to the cost calculation in project. You can look at the formula in cell V7 on the register sheet to see how this function works. Its first argument is the amount of cost to be added. In this case, it is a reference to cell S7, which in turn has a formula that multiplies cells D7 and R7. Cell D7 determines whether the risk occurs, with a value of 0 or 1, and cell R7 determines the amount of the cost impact, sampled from a risk trying distribution with min, most likely, and max values in the cost impact columns. Therefore, the amount of the cost impact is either 0 if the risk does not occur, or the value sampled from the risk trying distribution. Note that a risk make input function is also used in cell S7. This helps with sensitivity analysis. At-risk uses cell S7 as a single input in its sensitivity analysis and tornado graph, instead of picking up the simulated occurrence and cost impact functions as separate inputs. You will see one bar in the tornado graph for the impacts of material price risk, even though this risk is defined by combining two separate distributions for simulated occurrence and cost impact. The linking of a risk register to a schedule is best shown during a simulation. First, you can toggle the at-risk dice button to random and then press the F9 recalculation key a few times as you watch the register. You will notice that the occurs cells turn red when a risk occurs. The red is actually caused by conditional formatting. When a risk occurs, values are then shown in the register for the schedule and cost impacts. These are sampled from the at-risk distributions that have been added to the formulas in the register. Now I will run a simulation, and as it runs, I will open the Microsoft Project window. Two new entries have been added, one for customer design approval risk and one for material price risk. If you watch carefully, you will see that when the customer design approval risk occurs, a new taskbar appears in the schedule with the design task as its predecessor. The length of this new task changes depending on the size of the schedule impact of the risk. The bar enters and leaves the schedule depending on whether the risk occurs or doesn't occur. Similarly, when the material price risk occurs, a black diamond is displayed at the date the cost is introduced to the project. This cost is then added to the project's cost calculations. If you were tracking time-scaled costs during the simulation, you would see the new cost from the risk show up in at-risk's time-scale data report in the time period the risk occurs.